All right. Today we're going to talk about more factoring quadratics in Algebra 1. And this is a continuation for extra credit on what we talked about for last spring break. So we're going to do a quick little review and then move on to the new concepts that we're going to work on for extra credit. The essential questions that we had before are: what patterns do you notice when you use the generic rectangle and diamond problem to factor the quadratics? And are there any quadratics that cause a specific pattern? What is that pattern? From before, the question part that I want you to have for your notes for this would be the second question there, and there's a little bit more to add to that in just a little bit. So pause at this point. This question you do not have to do because you should have done that for the first time, and then the second question you should be answering, and then add the essential questions when we get to that. So you can pause to get that copied down and then start when you're ready. So just to review the factoring quadratics using generic rectangle and diamond problem, what we found out is that what I'm giving you there when I say a factor is the area of a rectangle, and we have found that that area really ends up being in four different parts, and those three items have to be put into those four parts, which means one of the parts has to be split. We know that this part ends up being n squared, and this part here ends up being the small squares, which are the ones, the part with the n squared. Right here is the big squares, which are the n squared. And then the rectangles, when we're using the algebra tile, get split between these two sections. So this 8n has to be split between these two sections. And so the reason we use the diamond problem is to help us decide how we're splitting those two items, or the 8n, into two different sections to make it come out, so that when we multiply it, multiply our numbers that we get here and here, we get the number 12. Now, one of the patterns that we found last time we kind of started going through this lesson, and some of the lessons before that, is that when I multiply these two items together, I get the same answer as when I am multiplying these two items together. So the answer for this section here in purple has to be 12n squared if I'm multiplying those two items together, because the answer for the other direction is also 12n squared. So whatever goes in those two boxes, the 15 items right now, it has to multiply together to make 12n squared. And so that is part of what we use, information part of what we use as we work on our diamond problem. So let's take, I'm going to clear this and we're going to build this back again. And so putting it in our rectangle again. And then we know the n squared goes here, and the 12 goes here, and what gets added these two items here get added to make the 8n, but they also have to multiply together to make the 12n squared. So we're going to use our diamond problem to help us with that. Remember that we multiply this times the coefficient here, which the coefficient here is 1. So that's 12 times 1, which is 12. And then we look at the two empty spaces, and those have to add up to 8. So 8 goes in the bottom. So we look at the two numbers that multiply together to make the 12, that also add together to make the 8, which happens to be 2 and 6. So I'm going to take that, and I'm going to put 2 n's here, the 8n, and the other 6 n's here. And then I'm going to look at the factors of the columns and or the rows to see what figure out what the length and the width of the rectangle is, because I gave you the area, and I'm asking you, when I say find the factors, I'm asking you to find the length and the width. So as I do that, I'm looking, as I look across here and here, these both have an n in common. I can divide an n into both of those. So I'm going to put an n here. And if I say n squared divided by n, that means I'm going to get an n, because n times n, the n times the n gives me the n squared. And then what's going to go here, I ask myself what number times n is going to give me 6n, and that number is going to be a positive 6. And then I look the other direction. I have an n at the top here. So what number here times this n is going to give me 2n, and that happens to be positive 2. And if I look, double check myself here, this positive 2 times this positive 6 is going to give me that positive 12. So now I have the factors for our problem here. So the factors are n plus 6 times n plus 2. Okay, so that's just kind of a quick review of using the diamond problems in generic rectangles to help us factor. What we're really doing is we're taking this problem and we're splitting it into grouping, kind of regrouping some things. So we have an n squared plus 2n plus a 6n plus a 12. And I can factor this part, and I can factor this part, and I end up getting these numbers up there as well. So I just have to figure out how to split them up, and I can use, that's why I use these two tools to help me figure out how to split those up. All right, so let's go ahead and skip over that one because we've got the same basic process. So let's look at this one. It says factor completely. And as I'm looking at this, I see a word I haven't seen before, which is the word completely. So that means there's probably going to be a couple steps to this factoring that we're going to not have it factored to complete all the way. That we may, once we do our first factoring, we probably will find something else that can we can factor again. So one of the things I notice on this is that all of these numbers are divisible by 2. So I'm going to just kind of look at this like I'm doing if I'm doing a distributive property problem, and I ask what I can divide each of those by, and since there's no room at the front, I'm going to put the 2 at the back. And if I say 2 times n squared, that gives me 2n. And if I say 2n times 2, that gives me 4n. And if I say negative 15 times 2, that gives me negative 30. So my first factoring is not the factoring using the generic rectangle and diamond like we did before, but to see if there's something in common that can be divided out from each of those. So I'm going to rewrite this as 2 times n squared plus 2n minus 15. And now I can see that I've got a quadratic polynomial there, and I'm going to factor my trinomial, quadratic trinomial, like I just finished doing with my generic rectangle and my diamond problem. And I'm trying to figure out how to split up the 2n here between those two rectangles. So I'm going to make my generic rectangle. And again, I know that the n squared is going to go here. My negative 15 is going to end up here. This is the patterns we've done before with this. And then I have to be able to split the 2n between the other two boxes. Well, I'm not quite sure how to do that, so let's use our tool that we've got. We know that the 2n is the 2 is going to go here for the 2n. We just don't need to write the n on it. And then I know that this times this gives me the same answer as this times this. And so these two numbers have to multiply together to get the answer of these two multiplied together, plus they have to add together to give me the 2n. So when I do that, I end up with on top negative 15 because this is a 1 times 2n. And then I have to look at the two numbers that I'm going to multiply together to make negative 15 and add together to make positive 2. And if this is a negative 15, one of the numbers has to be positive and one has to be negative. So therefore, 5 and negative 3 work. I have to have a positive 5 because the 2 is positive, and I need more positives than I do negatives. So I'm going to put 5n here, 5 of those n's here, and those 3 negative n's right there. And again, I'm going to look across and see what they have in common. They both have an n in common, so I'm going to put the n there. N times n makes n squared. Negative 3 times n makes the negative 3n there. Then what number times n is going to give me 5n, and that would be a positive 5. And the negative 3 times the positive 5 does give me a negative 15, so it looks like I've got good information there. So this when it's completely factored, I have the 2 that I had from before, times n minus 3 times n plus 5. And so now I have a completely factored polynomial there, and trinomial. Okay? So I'm going to skip that because it's the same kind of thing. So down here we had our essential questions for this lesson, for the extra credit lesson. It's what patterns do you notice in the problems we're going to be doing after this slide, and what makes these patterns special. So if you need to pause this and just as you can at any time, and restart when you're ready. All right, so here's what I'm going to ask you to do. I'm going to ask, so it's to factor the following quadratics. So we're going to, I'm going to ask you to pause this as soon as I finish giving directions. And I'm going to ask you to factor the quadratics that are listed here. And I want you to make a list of all the patterns that you notice that are happening with these quadratics. Okay? The first thing you do need to notice, though, and I know that probably a lot of you are going, well, there's only 2 numbers here, we've been working with 3 numbers. Well, there actually are 3 numbers there, we just don't see one of them. And if we don't see it, there's always going to be the number 0. So we could rewrite this as 4n squared plus 0n's minus 49. So again, just because it's not showing doesn't mean it's not there. We just have to use the number 0 instead. So you may want to rewrite each of those other 2 before you work on factoring and working through the problem and finish it, getting the answers to the factors of these problems. All right. Also, again, so one of the patterns that we notice is that when there's no number there, there's going to be 0 of those n's there. But there's more to the patterns, and I want you to make a list of those patterns, and we'll be looking for those in your notes for the extra credit notes. If they're not in the extra credit notes, all you've done is just copied what's on the slide. You will not get any points for this. So make sure you're putting some of your own thinking down on this page as you're doing this. So at this point, I'm going to ask you to pause the slide, go through, factor each of these, and then write down several patterns, not just one, not just 2. There's several patterns there. Then there's this that you might notice, and then there's some patterns that are common to all 3 of them, and those are the ones I want you to focus on the most. Okay? And then once you've written down several patterns and got everything, then you can start again and go to the next slide. So one of the patterns that you'll notice is for problems such as this one, is that this number right here is a perfect square number, and this number right here is a perfect square number. So that means I can take the square root of each of those numbers and it's going to come out evenly. And when you got your answer, the first part of that ended up being 2, which is the square root of 4, and the last part ended up being 7, which is the square root of 49. And you ended up with a positive and a negative there. So that pattern actually happened with each of those things. So if I had looked at the next one, and notice I did this without, yes, I do know kind of the answer, but I did know the answer because I know the pattern. And so for the next one, which is minus squared minus 1, I know that my answer is going to be like that. Yeah, do I want you to memorize these little shortcuts and things? No, I don't. If you kind of get comfortable with them and start using them because you're comfortable with them, that's fine. But please do not go away totally from your generic rectangle and diamond problems, because this only works for a very specific pattern. And I'd rather have you use one thing that works for all items, including this. But there is some patterns like this that we do need to start noticing because it will help us as we go forward on some things in the future. So we just need to be able to notice that sometimes there's specific patterns that happen, and I don't want you to memorize shortcuts on how to get to the factors. So just noticing what those patterns are. Okay, so here's another one, and again, I want you to try to work these through and work them all through, and then note the patterns that are happening here. And because there's some very specific reasons why we need to notice these patterns. The one pattern that I noticed back here is that we have a length times a width, and they're two different lengths of width. So this is going to make the shape of a rectangle because your length is different than your width. All right. So what do you notice about these? And again, pause this, do the factoring, write down several patterns that you're noticing, and then start when you are ready to continue. But please have those before you look at the next slide. Down quickly. So I know that this is 4x minus 1 times 4x minus 1. And so I want you to think about why I might be able to figure that out without doing the generic rectangle and the diamond problem. What is it about this problem that helps me figure it out very quickly? Let me do another one here. Let's do x squared plus, let's see, 6x. Excuse me, I didn't mean plus, I meant to do minus. Got a minus sign, a plus sign, 6x minus, x squared minus 6x plus 9. And I know that that is x plus, x, let's try that again, x minus 3 times x minus 3. And how do I know that during the generic rectangle and diamond problem that was what it was going to be? And how did I figure out that it was 6x in the middle? Is there a relationship between the 6x as well and the 3's there? So jot those couple things down. What you think the relationship might be, and maybe add to your patterns if you haven't already noticed a pattern there. Again, pause it until you get those down, and then start again and go to the next, because we're going to go to a new pattern. I thought the last one is this one. Again, you may have to look at this one, because this looks almost exactly the same as the previous problem. The previous problems, but there is a slight difference. And so how is this the same? How is it different? Again, factor the quadratics, look for the patterns, and maybe compare this pattern to the previous pattern or patterns. And again, pause it while you're doing that and come back together with me after you're done. Okay, so I'm going to go backwards for just a second. I want to look at these patterns here. Notice that this says 4x minus 1 and 4x minus 1, and there's a relationship between this subtraction and this, because negative times negative here makes it a positive, but then when I multiply some things, I get negatives and negatives, so I'm going to add them, I get a negative 8. And that same pattern happens, this similar pattern happens here, where this, I had the answer here that I got. So basically, this is the same pattern as the one before, except this time I used a plus between the 4x and the 1. And so I want you to think about why I used the plus between the 4x and the 1, and the previous one I used the subtraction sign between the 4x and the 1. And also, if we think about the x, it wasn't x squared, but it was something similar, 6x plus 9, I end up with, this is x plus 3 and x plus 3. And there's a relationship again between that 6 and these 3's here. There's also that with tied to the 9, but there's a relationship between the 6 and the 3's, and what is that, and where did that come from? We'll talk a little bit more about that as we go to in the future, or as we go to a lesson in the future. But I want you to start seeing and noticing the pattern there. Also, what shape do these make? The very first pattern we saw with the 4x squared minus 9 and so on, that we said made a rectangle. But what shape did these make if I had to build this with the algebra tiles? And hopefully, as you thought about it for just a second, that you answered this would make a square, because my length and my width are exactly the same. And if you think about this idea of a square, again, this is a perfect square number and this is a perfect square number. And so there's a relationship there, and that's again why we call certain, that's why we would say we could rewrite this as 4x plus 1 and that quantity, and then square it, because it's making the shape of a square. The length times the width is the length and the width are exactly the same, so we know that has to be the shape of a square. And so with that, and I haven't given you all the patterns because I want you to see have some more of those patterns written down, and I want you to be a little more specific and pulling out a little bit more vocabulary stuff with that. So I want you doing some thinking about this. With that, here is our summary. How do we factor quadratics? So I want you to basically give me the steps for factoring quadratics. How do we do that? Using our generic rectangle and diamond problems. And then just do a quick summary of the patterns that we found going through these kind of special pattern types of quadratic trinomials with everything, because we'll see some special kinds of patterns. That's when, in this case, it's when they make a square. And so we found, the first thing to say is we found some patterns that make rectangles, and special kinds of rectangles, and where you have like 2x plus 3 and 2x minus 3. And think about when we get that, and then sometimes we end up with squares as our shapes when we build the tiles, and those are the last couple patterns. And how do we know, and how do we know when that's going to happen, and what does that look like? Think about those patterns for those. And again, just summarize those. And with that, this is your extra credit opportunity, so make sure you take time, and remember I will grade these based on the Cornell Note rubric that's in the doc sharing file, so make sure you find that and pull that out and look at it to make sure that you've done things like underline vocabulary words, highlight important ideas, like maybe some of the patterns or some important ideas you might want to highlight. Not every single thing, but you know, just highlight everything. Highlight some things that are very specific and important to you or important to the ideas of the math. Sometimes it's not about important to you, but important to the ideas of the mathematics. And make sure you have a summary as well as your answer to your essential question in the summary section of your notes. And then also a couple questions along the left-hand column. So just saying a few things you need to think about. Anyhow, thank you and have a great rest of the day.